Hello Twitch. How are you doing today? Fine, I guess. Okay. Today I will be playing. Today I will be playing TIS-100. First of all, just a moment. I have to fix this. Hold up. There should be return. Yes. Here we go. Toggle full screen mode. Okay, exit the desktop. I hope, svačam, I hope Streamlabs will recognize the game. No? Here we go. Okay. Now, I will first have to... Okay. This is a game in which you are basically... the backstory is that the character that you are playing as has found this old computer. And you are basically trying to fix it by reprogramming all the various different parts of the computer. We are starting with the self-test diagnostic, which is the simplest the simplest level. It's pretty pretty straightforward. Now let me just quickly shuffle through the menu. I have printed out. It looks like I will have to switch the location. Okay, this is going kind of slowly. Okay, let's do it just like this. Okay, hopefully... Okay, hopefully... Yeah. No, let's like this. Okay, so... I will keep attention to the stream because... I will have to keep attention to the stream because I don't want my model to actually cover any important part of the game. Okay, so like I said, I printed out the physical manual of the game. It's going to be important so I can keep track of all the different possible commands. It should be right over here. Yes, okay. Instruction set. Yes, I know I'm vulnerable. Thank you, antivirus. Very cool. So, yes, this looks good. Okay, so let's see now. I did play this game. I did play this game before, so I do remember a little bit of it. I believe I still remember the exact solution to this puzzle. So let's see now. Okay, if my okay, so shouldn't this result in... Okay, so the main point of this first level is to teach you how exactly to use the move commands. Move, up, left, It is left, right? It's not. Yes, it's left. Okay. Move. Is it right? Yes, right. Okay. Move right. No, wrong button. Move right. Oh, okay, I misspelled this. Down. So I copy. No. It's move up, down. Move up, right, and then at the end move left, down, and this should be it. Okay, this is like I said, this is by far the easiest by far the easiest level. Like I said, the entire point is to teach you how to use the move commands. Okay, return to the segment, but first of all, let me just. Okay, so the thing with move commands is that when you are moving a value, a variable from one node to another, you need to have the move command in both nodes. The node from which you are sending the variable and the node to which you are sending the variable. You can't move a number from one node to another without putting an appropriate move command in both nodes. As you can see, all levels are divided into 4x3 grids. The game is starting with a simple. What does the? Yes, this is called the basic execution node. What we are starting here is called apparently the basic execution node, unless I'm looking at the wrong part of the manual. I don't think I am. Okay. Node type T21, basic execution node. Node type T30, stack memory node, which is that kind of a node I believe we are going to encounter later on in later levels. And then a node type T31, random access memory node, which the manual says is not actually yet available in any TIS computers. The computer that we are trying to fix is called TIS-100. The manual seems to imply that there is something weird going on with this brand of computers. What I forgot to do is read the story bit for this level. Like each level has a little bit of a story. Like every level reveals a little bit of the story. Something. Can't find a pen right now, so I'm just going to take notes here. Looks like short-term storage. Got this one. At the swap meet today, a fella wanted 450 for it, but I talked him down to 200. Good deal. No idea who makes this thing. Never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Asked the guys down at the but no joy. Randy has a mystery on his hands. Okay, so that reveals how how the character actually got the computer. Okay, so return to the segment. Yes. So this game is made by a company called Zachtronics. I hope I'm pronouncing that correctly. And like all of their games are known for two things. Number one, all of their games are basically puzzle games that depend on finding out the right timing of the solution. Like it's okay. So in this level, yes, there was basically just one real solution. There really was just one real solution to the level. But in later levels, technically there are multiple solutions, and you just need to find at least one of them. Like in any case, the catch behind every solution is that you need to find the correct timing between all the parts, all the different parts of the solution. If at least one part of what you think is the solution is out of sync with everything else, it's not going to work. What you think is a solution is not actually a solution. Or maybe it is, but you just screwed something up and you need to fix something. The second thing that Zachtronic games are famous for is that they let you compare your solution with solutions made by other people. This is what you see over here on the left. Okay, so signal amplifier. So yeah, and like this is compared with everyone who played the game. The data is actually stored somewhere on the internet. You can see over here that different people. This is just the second level of the game, and you can already see. Wait, let me see. Is my model covering this? Yes, it is. Let me just quickly fix this. Okay, this is a little bit better. Okay. You can see on this left side over here that this is just the second level of the game, and you already have people who what was that? Oh, hello there. Thank you for the follow. I much appreciate it. Hello there. I'm doing fine today. Thank you. Welcome to my stream. I hope you will enjoy. How are you doing today? While you are typing something, let me just finish my thought. This is like I was saying. I'm also fine. That's nice to hear. Anyway, how's your streaming going? It's going fine. This stream is the first time that I actually encountered the problem where my model was actually covering up an important part of the game, so I had to do a little bit of shuffling around in Streamlabs. But I just started. We will see what the game is going to be like later on. Like I was saying, this is just the second level of the game, but you can already see on the left side down here that people found different solution to the same puzzle. You can see that there are actually different bars down here. Yes, I do. I do have some basics. Um, I'll go banner overlay. Yeah, I feel like I do have some basics. Anyway, create new program. Yes. So, read over here in the lower left, in the upper left corner. The game tells you what's the objective of this of whatever level you have started. This goes read a value from in A. Okay, sure. You can post a link. I don't know. Yeah, feel free to post a link, and I'm going to have a look at the first time where I'm able to. So, signal amplifier. Read a value from input A. Double the value. Write the value to out A. Okay, my Twitter. Just a moment. Just a moment. Oh, okay. I will have to check over here. Oh wait, is my Twitter username not visible in my in the description of my stream? Hold up. Okay, let's see now. At okay. Um, okay, that should be it. That should be the link. Just search for that. I don't know. I thought I did put the link to my Twitter account in the description. I will take a better look at it later. Anyway, double the value, write the value to out A. Okay, doubling. Okay, let's see now. Account. Okay, I think I do have an idea on how this should be done. So, move up arc. So, every node later on we will encounter special memory nodes whose entire purpose is like for now we are only dealing with nodes that can execute commands. Later on we will and like nothing else. Later on we will encounter nodes that store that act like that act as memory, but they cannot execute commands at all. However, as it turns out, even command memories have one single piece of memory. If you look at any command memory over here, if you look at the top right corner, you can see there is one square that says ACC. That's the small bit of memory that every command node has. You can put numbers in that. Like the proper memory nodes will be important later on when you need to deal with more than just one number at a time. The problem is that ACC command nodes can store only one memory. Memory nodes will be able to store more than one number. But so there is a way. Now, at first, this level might seem impossible. How exactly are you supposed to double take the number and then double it when, according to the game manual, there are no commands that can actually do math? Well, this is where you need to use the memory, this ACC memory. So, basically, the solution is this. You store the number in one command node. Then you send it to the memory. Then, just a moment, let me quickly see. Move. I don't think the move command actually deletes the number from the ACC memory. I think the number actually remains. Okay, so what I forgot to mention is that technically command nodes actually have two memories, ACC and BAK. The problem is that ACC memory is accessible ACC memory is the only memory that's directly accessible. Back memory is not. Back memory has to be accessed indirectly by swapping the ACC and the values of ACC and back memories. So yeah. Now, however, now that I look at the manual, there is one math command. It's called add. So let's see if this is how you are supposed to. Like, my first idea was to basically send the number from one command node to the other twice in a row, and yeah, that would actually be impossible without the add command. Okay, so let's see if I can actually do this with just one command node. I just sent some examples. Please check DM so we can chat there. Yes, okay. I will definitely check after the stream. Okay. So move up, down. Move up, right. And move left, down. So according to my initial idea, in this second node in the middle, I don't know if my cursor is actually visible in stream. Oh, nice! It is visible. Okay. So I can actually show with the cursor. Okay, so my initial idea is to send the story like. My initial idea was to store the number in the arc value here, and then send it twice, like in this node, and then send it twice to this node here. And then in this node you do the adding, and then just move the result all the way to here. However, now I suddenly got the idea that I might do the adding in this node right here. You just add arc to arc, ACC. You basically add ACC to itself. That is like in real life programming. Like I have some experience, I have a little bit experience with C and C++ in real life, and in real life that is possible. It is possible to add a variable to itself or subtract from itself and multiply and divide by itself. It is possible to do work with the variable itself, and it's working. Okay, it's working exactly as it should. Okay, and as it turns out, I have actually found the best solution that other players have found as well. You can see that other players have found you can see that other players have found other solutions, but those other solutions were slower. I assume they were adding. I assume they were doing the doubling in the second node, like what my initial idea was. I think. Oh, all right. I forgot to read the story again. Continues to baffle. Chatted with Bernie at IBM, and he says it sounds like something they'd come up with in the USSR. But then why is the manual in English? Like you can see from the date that the story is taking place in 1979. Like in the 70s, the computers were not the same as the computers that we are doing today. There were as many different computer architectures as there were different computer brands. Like every computer brand had its own like architecture, its own quirks because of its own unique architecture. I have actually watched one or two videos on YouTube, and of course wait, what am I trying to say here? I have watched one or two videos on YouTube about this, and like USSR actually had some kind of a problem with developing their own computers. Uh, if my memory serves me well, they actually had some problems with manufacturing semiconductors or something. Or is it that like they didn't really know what exactly they were doing? In any case, like compared to the West, USSR had some problems with developing their own computers. I don't really remember what exactly was the problem, but USSR had problems, and they were actually lagging behind the West because of these problems. I believe even politics were involved, and that also slowed down the progress. Yeah, IBM. And he says, it sounds like something they'd come up with in the USSR. Okay, so let's see. Return to the segment list, and I do plan to make to create a user account on GitHub and upload my solutions from this game there. The game does let you access your save files. Like over here, you can see the open save directory button. You can't see it right here because of what I set my Streamlabs to. Right? I yeah, you can't see it, but this button that I just pressed basically opens a window in Windows Explorer, where you can see it's like save files are literally just basic text files that you can open in a notepad. Like, you can't go simpler than that. Okay, so the first level was called self-test diagnostic. The second level was a signal amplifier. Now I'm going to play what's called a differential converter. I believe that's something about subtraction, if I remember correctly. Ah, yes. Okay. Pause. Okay, let's see now. Read values from in A and in B. Write in A minus in B to write input A minus input B to output P. Write input B minus input A to output N. Okay, so this is something that over here you basically have to use two different chains. Okay, so how exactly? Now, there is a command negate. Okay, so there is a subtraction command as well. I forgot that part. The value of source is subtracted from the value of ACC, and the result is stored to ACC. Okay, so because the result is like I said, like in these early levels, you relying on the ACC memory is pretty much obligatory. The problem is that it's kind of limited what exactly you can do with it. Over here, I will have to do subtraction and addition at different parts of the chain. Because subtraction is the problem. If it were just simple addition, it wouldn't be a problem. Like yeah, it would still be a problem if I were working with two different numbers. Yeah, like like it's not addition or subtraction themselves that are the problem. The problem is that you have to work with two different numbers at the same time, and like I said. The only memory you can access directly is the ACC memory. There is the back memory, but you cannot access it directly. You have to swap the values of ACC and back to access back. I remember that much. Okay, so let's see now. Obviously, okay, let's see now. Oh, you can actually press Ctrl A to select everything. Oh, okay. This is something I did not know was possible. I did not know it was possible. Wait. I think I'm looking to the menu right now. Like if you are playing this game, like it's pretty much obligatory to look at the manual. Without the manual, you just can't. You will just not be able to do anything. Okay, Control Z. Okay, so embedded interactive debugger, keyboard shortcuts. Control Z, undo last change. Control Y, redo last change. Control X, Control C, Control V, Control arrow. Control arrow, navigate to the adjacent execution code, a node. F1 view instruction set quick reference. Here we go. Yeah, you can see this is the entire the entire instruction set that's available in this game. If a command is not here, you cannot do it. The entire game is basically limited to this. The coordinate system starts at 0, 0, which is located in the top left of... okay, so visualization module. I believe that's something that's also going to be important in the later levels of the game. Mm, 30 characters. The standard TIS-100 visualization module is 30 characters wide and 18 characters tall. So, but this also starts at 0, 0. So I assume the maximum numbers that you can use for the coordinates is 2917. Okay. Okay, yeah, okay, yeah. There's one more command that I wanted to do. It's function F2. Okay, this is something that you cannot do. Erase this program, erase, because I have not actually done anything yet. Okay, okay. So this is something I discovered. The button that I just pressed is F2, and it shows this. F1 is to see all the commands. First of all, you can see here, this device is registered to Department of Defense Quantum Information Science Lab. I have a feeling that is foreshadowing. I did see, I think I have seen like on this video games TV tropes page that there is that in the later levels some serious shit starts to happen, like in the background or in the story. And I have a feeling this is foreshadowing. Quantum Information Science Lab. That's number one. Number two, there is an Easter egg here. And the manual actually hints at this. Because if you look at this page that shows the commands, you can see that the line that describes what the F2 button does is highlighted. And there are two question marks. I believe you have to press here. Yes. Okay, so yeah. Erase this program, erase. So yeah, you press F2 on your physical keyboard and then you press on the eagle. And you get this. These are basically advanced levels where the game doesn't actually tell you what you're supposed to do, and you need to deduce on your own what you're supposed to do by looking at the input and expected output. Of course, I will not be doing this yet because I want to do the basic levels first. So you can also create custom puzzles. That's something that I could also maybe perhaps do one day in the future. Anyway, differential converter. I have been talking for like the past 15 minutes without actually doing anything. Okay, so let's see now. Okay, it goes A minus B. That's A minus B and B minus A. That alone should tell you. I take so right at the beginning, it's obvious that you can't do the subtractions themselves in the first nodes. You have to do them in the second nodes, because you will have to use the first nodes for storing original unmodified numbers, so you can pass them on for subtraction. Okay, move. Okay. My first idea was to use the add command as the first command. However, if I did that, in the second, by the time I reach the second number, I would encounter the bug because the numbers would end up being too big. Like the end result will end up being too big. What you need to do is use the move command instead. Like if you use the add command, the existing command in ACK will get incremented. What you need instead is to replace the number, and for that you need to use the move command. So move up ACC. We do the same thing here. Move up ACC. Now, this is where it gets tricky. How exactly do we do the subtraction? Let's see here. Good question. Okay, it will obviously involve okay, so move up ACC. How did I do it the first time? Okay, so after the first step, the number gets stored in the ACC. Now we have to move them and then subtract them. Move ACC down. Move ACC. Move up ACC. And then, so in output P, it should be A minus B. Okay, so right over here, I have to use the subtraction. Subtract source. Description. Subtraction. Description. The value of source is subtracted from the value of account of ACC, and the result is stored to ACC. So this is what we do. Move ACC left, move right, down, sub for subtract, sub up, and then that gets stored automatically into ACC. Move ACC down. Move up, down. Okay, that should take care of input A minus input B. Now we have to take and then output P. Now we have to take care of input B minus input A to output N. For this, I believe it will go like this. Okay, you know what? To make sure it's properly synchronized, let's do it like this. Move ACC down. So, move up ACC. And now we do something similar over here. Move ACC right. Yeah, so now we basically repeat the same commands, but we substitute left and right. Move left down, sub up, move ACC down, move up, down. Okay, I think that should be it. Yes, it is. Okay, and there is no desynchronization at all. Okay. I probably should be using the fast command. Really? This is considered a slow solution. Really, this is a slow. Okay, first of all, let me check if you can actually see this. Yes, okay. Okay, you can see this. Okay, so this is allegedly slow. Like you can see where the arrow points at. How the fuck did you do it with only 5 nodes? What? There are people who do this with only nine instructions? And they do it in less than 250 cycles. Okay, so yeah, like I said at the beginning of the level, at the beginning of the stream, there are multiple solutions. And like the first challenge is just finding literally any solution at all. The second challenge is finding a more optimized solution than what you originally came up with. And apparently, yeah, there's definitely some optimization that I could do here. Okay, continue editing. Like I legit have no idea how to optimize this. Like, okay, so the problem, okay, so you have to have, because of the input and output, you have to have a node here, 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 and here. So I guess, like you can see, like you can see that some people used only 5 nodes. I guess that those people found some optimization here. I think I do have a general idea of how to optimize it. Your base. Yeah, I assume you basically do all the subtraction in just one node at this part of the chain, and then you just pass it here. Yes, first number here, second number, like first number directly down here, second number here, here, here. I assume. Okay, let's see the story. Interesting. It looks like there's some kind of static memory in this thing, encoded something or other. Like I guess. Like in this node you basically delete this command, and then you rewrite this to send to the left node twice instead of down and the left, and then you do something here. Okay, stop. Let's see. Return to the segment list. Okay, so let's create a new program. I think I have an idea. Move up arc. Move up arc. Move arc left, and again move up, move arc left, and over here move left down, move up down, move, oh, I always do this, move up right. Okay, so first it goes A minus B. So it's move arc down, move arc, move up arc, and now it goes move left down, at which in which case it goes subtract up from arc and then okay, move arc down. No, it's move right. Okay, so this would have been a bug because I accidentally specified a wrong node. This would have been a bug, and because there is nothing in the left node, the program would have stalled. Move right down. No. Yes, sub up. And then you do the same but in reverse. Arc down. Move up arc. Sub arc up, sub up, move arc down. I believe this should be it. Dude. Okay. Okay, so optimization achieved. Ah, so it's actually 4 tests, not 3. Okay. Bro, what the fuck? Return to the segment list. Really? I used one less node, but I ended up using more cycles, 40 more cycles, and one additional instruction. And okay, I think I see. Okay, I see what the problem is. Okay. Copy. Here. Okay. Okay, you can do the second subtraction right over here. Yes, just a moment. Move right. Is this going to work? Sub right. Okay, what? Okay, so move okay. Move account down. Okay, so what exactly is the problem? Sub right. Okay. Sub up. Move account down. Okay, okay, so it looks like it looks like it's not. Okay, so it's time to debug this. 44 minus 49. Okay, move. Okay, what? Okay, so this is going to be a hacky solution. Okay, so there is one command, negate. What this command does is change it negates the value. The value of ACC is arithmetically negated. A value of 0 remains the same. What this means is that a positive number becomes negative, and the negative number becomes positive. Let's see, is this going to work? Yes, this did work. Okay, so this is technically the most optimized solution that I have had up until this point, but it's still not as optimized as other players did. Wait, move up. But wait, why did this problem suddenly start appearing now, but it did not appear in previous situations? Arc, sub arc, move arc down, move up down, move up down, move up right. Okay, so the problem is definitely not here. So the problem is definitely over here, but this is such a weird this is such a weird problem. It's the right now. It's the right number. Like it's like it doesn't subtract correctly. Okay. No, wait. That shouldn't be the problem. The addition is done over here, not here. Like if the addition was being done here, if the addition was being done here, like it should be the exact same number like in the input, right? Not the exact same sum. Move up ACC, move ACC down, yeah, for adding. Move right down, which should happen only over here. Subtract
Move arc down. Yes. Okay. So move arc down. Okay. So it's not the addition. It's not like the second subtraction is the problem. Like second. Why? Why is the second subtraction the problem? Okay, move arc down. Okay, that's not the problem. The problem starts appearing over here. Wait, what? Wait. Wait, move right down. Yes, this has to be done for the sake of the first subtraction.
Okay, if I add, okay, so the exclamation mark is the breakpoint. When the simulation hits the exclamation mark, it immediately stops. This is good. This is good for debugging. Okay, let's see what exactly is the problem here. Subtract left. Wait, no, wait. Wait. Okay, I should be return. Okay, so copy. Yes. Okay, so oh, okay, I will have to do this again. Um, shit. Because this is really bothering me now. Move up, down. Yes. Sub. Right. Okay. Okay, so this is the problem. Let's see now. Okay. It says sub right. Okay, so yeah, I don't really understand why the number. Wait, what? What if? What if? What if I put the negate command here? Oh, okay.
and then yeah, yeah, like I'm genuinely confused now. Like I could just go for the easy solution
and add the negate value, but
okay. I think I understand what's the problem here. The problem is that I'm doing the subtraction here. Move right down. What happens now? Okay, so now it's working correctly. I I have yeah, the amount of cycles has once again jumped up compared to my first solution. Yeah, like compared to my first solution, the amount of nodes has decreased. The amount of instructions is the same, but the amount of cycles has suddenly skyrocketed. Like, wait, am I supposed to like, how exactly do you do it with less instructions? Like, you have people who are doing it with what, 10 instructions? 12? Something like that. Yeah, I legit don't know. Wait, let me quickly check something. Oh, okay, I will have to. Okay, where is this? Okay, documents, my games, TIS-100, number. Okay, some random number, save. Okay, I will have to change in my papers the location of where exactly the game keeps the save files. I originally played this game with the DRM-free version, that which I don't even know where I got. And right now I'm playing the Steam version, and it appears that the name of the folder is slightly different. So, okay, signal comparator. Okay. Bro. Okay, read a value from input. It's not a value, it's a value. Write 1 to G if greater than 0. Write 1 to E if if equal to 0. Write 1 to L if lesser than 0. When a 1 is not written to an output, write a 0 instead. Okay, first of all, did I read the story for this? I think I did. And coded something or other, yes. I read the story for this. Okay, so. Okay, so in this over here, I will have to use these conditional instructions. There are a couple of conditional instructions which look at the value of the number in the ACC memory. Move arc down. Move okay, wrong. Move up, down, move up, down, move up, right. And now over here, move left arc. Now, this now over here is when we have to start doing commands like conditions. Like there is no simple if command here. Like in modern programming languages. Instead, you have 1, 2, 3, 4. You have 4. No, 5. 4. You have 4 conditional commands. If the value is 0, if the value is not 0, if the value is positive, that is greater than 0, and if the value is negative, that is less than 0. We are looking at okay, so G is positive, E is negative, E is equal to 0, and L is negative. So, and they do not work the exact same way as the conditional branches do in real life. Like, not only do they look different, but they are actually used different. Like in this game, I know that what I'm just about to say is going to sound horrifying to any experienced programmer, but in this game, the conditional branches are basically the combinations of real life conditional branches and go-to commands. Let me tell you one thing. In real life, I went to programming courses as a part of my high school education. One of the most basic things that you learn in a real life programming course is that you have to avoid using the go-to command as much as you can. Like, that's even if the person teaching programming doesn't actually mention the go-to command at all, if you bring it up, the instructor is going to tell you, no, don't use it. Don't use it. Avoid go-to as much as you can. In this game, you have no other options. You have to use something that behaves like a go-to command, because there is literally no better option. The game literally does not give you any alternative. You have to use go-to in here. Something that acts like go-to. So, output G, that has to be greater. So in here, we have to use, where is it? Over here, we have to use the command jgz. This is the command that this is the conditional command that looks at if the number in the ACC memory is greater than 0. That's that's what G stands for. G, greater. If I write Jn, it's basically, where is it? I am not sure what exactly J means, but GZ means greater than 0. JNZ means not 0. JEZ means exactly 0. And JLZ means less than 0. I assume, like, as far as I'm concerned, that's literally the only explanation there is. So over here we go greater than 0. Yeah, okay, so this is the syntax. This is the syntax for this command. you write the command itself, and then you write in the label. Oh, right. Wait, what's the label? Ah, yes. Okay, I have to write colon. Okay. Oh, there is no tab, really? I have to use the space button. 1, 2, 3. Okay, let's make it look good. That's 1, 2, 3. 1, 2, 3. Okay, so greater cetera means start. This is the label. The lines that have a semicolon are labels. The labels are not predefined. You write in what you want for the label. In this case, I will declare that str means start, gre means greater. You know what to do if the number is greater. Okay, so in this case, one and then exa means exactly the 0, and low les means less than 0. Okay, we write here exactly 0, go to exa, and less than 0, jlz, less than 0, go to les for less. Okay, 1, 2, 3. In this case, move 1 down, and okay, so now and move, let's go with -1. Let's just go with ACC. Move ACC right, and then I will do some comparison. Wait, no, I think I could, or I think. Wait, no. Actually, I think this optimization would actually not be optimization at all, because the only thing I'm doing is working with a different number. Yes, but okay, and what's the... There should also be an actual go-to command. The next instruction to execute will be determined by the value in ACC. Really? Oh, wait, I don't need to use this label. Wait, I don't need to use this label. I can just...
Wait, I could use JRO. JRO command is basically JRO is a special command. It's similar to J something Z, but it allows you to use it's unconditional instead of conditional, and it allows you to use numbers instead of labels. This would save me on that would actually save me on space in this node over here. That's JRO. That's 1 to minus 1, 2, 3, 4, 5, 6, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, so the question here is, should I go to -6 or -7? Yeah, the question is, how exactly does this command treat labels? Does it skip them? Does it skip over them, or does it count them as well? Okay, for now, let's assume it counts them as well. 1, 2, 3. Move wait, optimization. Okay, optimization. I was going to write two different move 0 down commands. But could I actually write just one move 0 command if I'm careful with how move 0 down? Actually, that's not important right now. Actually, I don't even need two different blocks at all. I can just use one block for both exactly 0 and less than 0. Because in either case, because in both cases I output 0 here and send the value of ACC here. In each case I have to modify this as well. Actually, I will need two different commands. Exactly 0 ngr for not greater. ngr for not greater, and jlz again go to ngr not greater. In both of those cases it has to be move 0 down, move ACC right. I'm a genius. Move left ACC.
once again, oh, this is where I will be able to use just two conditional branches, exactly 0 and not 0. Exactly 0, go to exactly 0. And like I did not need to put the JRO command here because because it automatically when it comes to the end, it automatically wraps back up to the first command. So yeah. Exactly 0. Yes, okay. So, and then JNZ for not 0, NEX, not exactly 0. Okay, perfect. And now, and now, okay, so if it's exactly 0, okay, I forgot to put a comma here. Move up, down, move, and then you do not need to do any comparison here, any conditional branches here, because by this point everything has already been done over here. Move 0 right, and over here you simply put move left down, because by this point if it's not equal to 0, because by the time you reach this block, if it's not 0, it's obviously less than 0, because greater than 0 has already been handled here. Not in this situation, if it's not exactly 0, then it's obviously negative. So because like I just said, the positive number has already been handled here. And then of course JRO minus 6, because there's one less number. And over here it's 1, 2, 3, move 0 down, move 1. Okay, so if I get some kind of a bug here, it's going to be the sign that I have screwed up JRO commands. Yes, okay, I have screwed up the JRO commands, obviously. Let's go. Wait, what? Wait, what? Okay, the JRO commands are acting correctly. Wait, what? Just a moment, I'm experiencing something weird. right over here it's 0. The next number over here should be 0. No, wait. -2. No, it should be -2 because this, this is not taken at all. So, -2. Okay, JRO commands are working correctly now. 1, 2, 3, 4, 5, 6. So JRO command ignores JRO command ignores labels. Okay, and now that I think about it, I know what the problem is. Okay. Is it though? Okay. Just switch this. Okay. Because like because the way I wrote this, there is a chance that it will pass the a great number, and this simply looks a positive number, and this simply looked at whether it's 0 or not 0. So when it was a positive number, this passed number 1 when it should have passed 0. Okay, I will have to put one additional JRO -3. In which case this has to go again -6. Is this going to be it? What the fuck? 1, 2, 3, 4, 5, 6. The fuck? Oh, bro. Okay, I have screwed something up. There's now. Okay, okay, so this is what I said. There is something wrong about the tempo. Okay. What exactly is the problem? The problem happens when the number is positive. When the number is greater than 0. Wait, why did this not work? JRO -3 JRO -6. So not only does this suddenly start putting up wrong outputs, but it also desynchronizes Okay, I have no idea what. Okay, this has to be JRO minus 5. Yes, it's because this gets done regardless. Wait, what? X less than 0. Have I already been playing this for 2 hours? Really? Okay. Um. I have no, yeah, the problem is what happens if the number is positive? Less than 0. Okay, I have to do. Wait, I think I have an idea. J, G, Z minus 1. This. Really? Really, I cannot use the numbers for this command? Really? Okay. Okay, I think okay. There are actually two commands for jumping between two unconditional commands. One is JMP, the other is JRO. So J, E, N, G, and L, Z apparently have to work. Okay. This is something that I did not originally notice. So JRO works with text-based labels, but all other jump commands work with numbers. Okay. I believe this is where I will have to use the start label. What happens if it's greater than 0? If it's greater than 0, yeah, the problem is that this command was doing this if it was just a moment. I think I will have to redo this. Okay, first of all, I should remove this command. Wait, was this command the problem? Ah, okay, 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 okay. Was this command the problem? Wait, I don't think so. Yeah. Wait, what did I just a moment, Control Z, Control Z. I have no idea why I deleted this. Because it has to do it either way. If it's exactly 0, ah, okay, okay. So the problem is that either way, the problem is the fact that either way, regardless of what number it is, I'm sending it to the right. If it's not great, yeah, like, just a moment. I have a feeling there's a problem somewhere in here. Um, wait. Not greater than. Not greater. So obviously. Wait. I know I did it. I know I did it this way when I was playing the game the first time. I did something like this, but now I can't remember the solution. Um, wait. It doesn't matter either way. The problem is definitely somewhere in here. If it's exactly 0, if it's not 0, go to. Okay, I think I used the wrong command here. Is this going to work now? Okay, so the problem here is now when the number is positive. Yes, because of how this works. Yeah, it should be telling it to. Okay, yeah. Okay, so it outputs it should be outputting 1 only when the number is negative, but it outputs when it's positive as well. So I have to do something here. not 0, no, Control Z, not 0. Kada je lesser than 0, JLZ, go to this. Kada je greater, go here. Oh god. Lesser than 0. Yeah. Okay, so I have to do some restructuring. This is when it's lesser than 0. Less 1, 2, 3, 4, 5. Okay. I mean, not okay. You know what? I'm thinking too much. Let's just brute force it. I will handle optimization when I oh Christ, JIO minus 1, 2, 3, 4, 5, 6, 7, 8, 9. One, two, three. If it's greater than 0, move 0 down. Move 0. Yeah, it's working now. The problem is that this is really not optimized. Yeah. Yeah, the problem is this is not optimized at all. There are some people who have really less than 300 cycles. Yes, yeah, you basically have to use 6 nodes. No other way. Instruction count statistics. Yeah, there are some people who used less than 20 commands. Really, continue editing. Yeah, like I have a feeling that I could optimize this node here. This node here is the problem, I feel like. Is it? Like I have a feeling that both of these nodes should be optimized, should be more optimized. I just don't really know how exactly. And 6 minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, like I did manage to brute force this, but aha, okay. Return, copy. Okay, I see what the problem is. Is that really the problem? Like, like I have a feeling that in one of these two commands, I shouldn't be passing the exact. I have a feeling I should not be passing the exact value of the number. I have a feeling I could. If it's exactly 0, not if it's 1, yeah, it definitely has like I'm trying to figure out how to optimize this. I have a feeling it has something to do with what number this node is transmitting to this node, and then what this node is doing with that number. Like it still has like one of these two nodes. Like even if the number is not greater than 0, you still have to look at if it's 0 or less than 0. There, like I feel like my brain is just stuck. Oh, by the way, of course I forgot. Story. Found a block of static memory, but it's in a proprietary format I never saw before. Can't make heads or tails of it. Oh brother, there's just too many different kinds of machines coming out now, and I like tinkering with them as much as the next guy. But when every Tom, Dick, and Mary implements their own memory address scheme, it's all. I say the bottom's going to drop out of the I say the bottom's going to drop out of the microcomputer market soon. Mark my words. Yeah, basically the guy is saying, oh, why does every single computer manufacturer create their own standards? Like, there's definitely something that could, some kind of an optimization that could be done over here. Yeah, like I have a feeling I know what to do but not how to do it. Like I have a feeling it's all about what number is transmitted from this node to this node. Anyway, yeah, let's not spend too much time on this. I will delete this. I might come back to it later. Okay. Signal multiplexer. Wow. Okay. Signal multiplexer. Okay, first of all, before I forget, let's read the story. I might have an idea of where this TIS-100 machine came from. Described the architecture to Fred at Motorola. I described the architecture to Fred at Motorola, and it says it sounds like it was designed for signal processing. That got my brain going. Government project maybe, something the CIA cooked up to comb to Soviet radio signals. Hush hush top secret. Maybe. Could I be in a possession of a classified device? Something for spooks? I might have to sit on this one for a little while. Anyway, what? Okay, a signal multiplexer. Read values from input A and input B. Input A, input S, input B. Read values from A and B. Read a value from S. Write input A when S is okay, write input A to over here when S is -1. Write B when S is 1. Write A plus B when S equals 0. Okay, okay, this is easy. Okay, so yeah, I say easy and then I have no idea how to optimize it. Yeah, move up. Move up, right. Move up, left. Move up, ACC.
Okay, once again, JGZ, JEZ, JNZ. JGZ greater, JEZ exactly, and JNZ less. EXA LES. Okay, so when S is 0, when S is greater than 0, so just a moment, when S is greater than 0, write B. One, two, three. Move right move right down, and over here we have to use a new command. Move left nil. What this means is that the number is red and then nothing. The value is simply red. This effectively skips a step and allows this node to continue forward. If it's exact, move up, down, move up, down. If it's exactly 0, 1, 2, 3, move left ACC, add right, move ACC down. Oh god, I'm going to run out of space here. That's not good. Wait, am I actually going to run out of space here? One, two, 3, 4, 5, 6. That's -6. Oh god. Okay, it looks like I'm going to run out of space. If it's less than 0, write A. Okay, I just remembered what's the optimization. Okay, so I just remembered what's the optimization that I used the first time I played the game.
You can write literally anything here. If this is greater than 0 or exactly 0, this command, if it's greater than 0 or exactly 0, this command is skipped. If it's not greater than 0 or exactly 0, by logic it's lesser than 0, in which case this command gets executed. Okay, I completely forgot that this is what I do. I did this the first time and I actually forgot about this. Okay. Move. Okay, I will have to leave this empty as a reminder for myself. Move. If it's exactly 0, move left to account, add right, move account down. Okay, greater than, if it's less than 0, move left down, move right nil. Aha, of course. 1, 2, 3, 4, 5, 6, 7. Hold up. The problem happens. Okay, so the problem happens when okay, move up to ACC. Okay, if it's greater than 0, it has to write B. Move left. Oh, okay, let me just quickly. Okay, I think I'm using this. The wrong way. Okay, I think I'm using this the wrong way. Wait, just a moment. I think I'm using this the wrong way. No, I'm pretty certain I'm doing it right. Yeah, move left nil. Yeah, obviously. Yeah, I'm pretty certain it should be nil over here. Okay, so if it's great, if s is greater than 0, write 1. Move right. Okay, move up left. Okay, down. Move nil. Okay. Okay. This is the problem. minus 1, 2, 3, 4, 5. Okay, I forgot the return. Okay. Nice. Oh, nice. I actually did. I actually did this okay. I'm at the very top when it comes to both nodes and instructions, and I'm slightly above average when it comes to the amount of cycles, which means that I could. Yeah, the problem is in the amount of cycles. I'm using the right amount of nodes and instructions. Wait. How am I... Okay, so using the same amount of instructions, I should get a lesser amount of cycles. Really? Same amount of instructions, but a lesser amount of cycles. How is that even possible? I legit have no idea how is that supposed to be possible. Same amount of instructions, but a lesser amount of cycles. What the fuck? Move. Wait, is it something about addition? I don't think so. If I try to move the addition to this node, I have a feeling I will only screw everything up. Move left down, move right nil. Yeah, I have no idea. I have no idea where to even begin with optimizing this one. I legit don't even know where to begin with optimizing this one. As far as I'm concerned, this is already as optimized as it could be. But some people actually found a way to optimize it even more, while keeping the same amount of nodes and instructions. What? Anyway, um, Anyway, let's see. Let's start this one. Sequence generator. Sequences are zero terminated. Read values from input A and input B. Sequences are zero terminated. Read values from input A and input B. Write the lesser value to out. Write the greater value to out. Write 0 to end the sequence. Okay, okay, I have a vague understanding on how to do this. A vague idea of how to do this. It would involve subtraction. Yes, you basically subtract one number from the other, and then you do something depending on what the result of that is. Let's see the story. You know what? Let's. Okay, yeah, like I already opened this. The new girlfriend is encouraging me to get rid of the microcomputers I've accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. Going to wait on this one though. Never found out what its whole deal was, and if it turns out to be something I wasn't supposed to have, I think I could get in trouble. Cleared a little space on the workbench and hooked it up. Still works beautifully. Yes, it is a beauty, this one. Notice how the year changed. In this one, it's 1979. 1979. It appears to be a couple of months later. (1979). It's still the same month. Is yeah, I like. It's still 79 again 2 months later. Now it's the 1980. It's 4 months later, and then there is a time skip from 1980 to 1994. 1994 is where IBM machines started appearing, right? And it's the standardized, like DOS. Yeah. Yeah, like that's where the computers started being standardized. Okay, so I think I'm going to call it quits for today. I'm pretty certain I will be able to fulfill this is actually this stream actually took more time than I expected. It's already 2 hours. Already 2 hours and 35 minutes have passed. So I will definitely do these two puzzles. In the next stream, I will actually have a second stream. Like my first idea was to have just one stream because when I played the game for the first time, signal edge detector, I believe, is where I got stuck. So I will definitely be able to do at the very least this puzzle, and then I will at least try this. Yeah, I think this will be possible as well. Anyway, I will actually have a second stream. Yes. Okay, so where is okay? So yeah. So okay. So thank you for coming to the stream. I hope you enjoyed it. I know there was a lot of nothingness because of how much I was thinking, but yeah. Thank you for coming. I hope you enjoyed, and I hope you will come again. Goodbye.